Hello. How did you all come here today? Did you walk or did you take a tram? And how was your experience coming here? And what components do you think that determined your experience? I live in Boston, so I flew here 2 days ago, and I walked today. And since the COVID-19 started, it was my very first time traveling abroad for a conference, so I was very excited to come here. And because you have to be physically there to experience something, and that experience is something that I would like to talk about today. So hello, my name is Eunsu Kim, and I am an interdisciplinary designer, and I would like to talk about what you can experience and what you feel, how you feel in the cities, and then how we can measure them. So we all know that how cities are designed is very important now in our daily lives. And so how many open spaces do we have in our neighborhood, how greenery that is, how the road structure is designed, how bike-friendly it is, and so on. And because all these things influence what we experience in everyday life, everyday experience, it is very crucial to us. And then sometimes even how cities are designed, that influences the way that we think, and sometimes the way that we make decisions. So we spend a lot of time in public spaces. The streets, we just walk around, we just go for a stroll. And so the public spaces, that's where all the social activities and human interactions happen. And then what and who we encounter in there, that's one of the main components that impact experiences. So many urbanists talked about how important it is to focus on these public spaces, and then Yang talked about how important we need to understand the spaces between buildings, and then it needs more attention, etc. So that's the analog of the city, and then non-technical side of the city. So let's talk about something about technology. So with this advanced technology, we have abundant data in terms of its quality and quantity and its variety. And then we have a computational power, which we didn't have before, that's allowing us to compute high volume of data, be computed in a second. And then we also have like AI models that predict many different things at a high accuracy level. And to talk about data, even tiny and seem to be trivial things in our life are collected as a data. And then sometimes we agree in order to use some services in our smartphones, we agree that some interactions with the phone or GPS, those to be collected and rendered into a data format. And then the cities are publishing their open data, publicly available, like infrastructure data, census data, and public health data, and so on. And then even individuals can collect their data by installing some sensors throughout the city. And with all of these, things are interconnected, and then we are creating completely new values. For example, in cities, it helps us find the parking spot, it helps us find a shortest route to the destination, report the potholes, and etc. So basically, our life became much more convenient. However, when it comes to design for the urban lives, we need to pay a little more attention to how we can do about like human components to design the city, because it's closely related to our daily lives. What's available to us here through these technologies may shape the way that we think and way that we behave here. And then, fortunately, I'm not the first person who talk about this human-centric point of view in smart cities. Actually, it's been discussed for quite a long time, and then there was a concept of like smart city 1.0, 2, 3, 4, but then the trends of it has been quite clear that it started to be led by some tech companies like IBM, and they wanted to use their innovative technology for the cities. And then the city municipalities, they took their own actions. So they were trying to leverage the public open data, and then they tried to improve their city services. And then the citizens are trying to create their own values throughout these data. So these things that allows citizens to interact with their own environment and then city governments with their in a new way. And coming back to the public spaces, so that plays a significant role in shaping experiences, as I said. And then in particular, collecting data, AI models, I think those need to be in a way to inspire social cohesion and to stimulate social interactions, and then ultimately to enhance the quality of an urban life. Then what can we focus on in order to measure different facades of the cities? What is actually the human-centric approach? So I would like to just talk about how I approach this in a slightly different angles with 3 different projects. So these are my projects that I want to introduce today. So the experience, emotions, and behavior, that's what I measure throughout these projects. And then the first one is a journey as destination. And in this project, I try to measure experience. So here, in the first school, in my grad school at Harvard, I was living in this dormitory, and then I needed to walk to the school building every day. So I was completely new to the city, so I just opened the Google map, typed origin and destination, and voila, I just got this route, which I followed for the entire year. And then, just accidentally, I discovered this like beautiful magnolia tree and then sweet gum trees just next to my school building. And then soon I realized that that could have been my commuting route for the entire year. So for sure, it's not the shortest, but it could have been just like half a minute longer, a minute longer, and so on. If I just only if I knew it from the beginning or a little earlier. Then I started to think about efficiency versus experience. So the navigation apps that we have, that's only giving you the time-based information. They may have other metrics to compute those routes, but it doesn't tell you about how they computed their route and so on. And then I was thinking, is that the way that we really want? Although the pedestrian experience is something that's really hugely impacting on our daily experiences. So to talk a little more about the pedestrian wayfinding, so I started to question these. Can we, maybe we can offer more information other than just time-based information, and then maybe we can find the best route based on the people's preferences. And then maybe we can enrich the pedestrian experiences by offering those alternatives. Then I started this project, Journey as Destination, that is measuring experiences to improve the route choices. Then I was questioning, so what determines the quality of pedestrian experience? What kind of factors are actually impacting their perception to each route? So there were several, so I started to look at the literature, and then there were several urban qualities defined, the Ray Ewing, Susan Handy, and then like there were those were like 5 qualities, which is imageability, inclusor, human scale, transparency, and complexity. And these qualities are affected by the physical features on the street, such as sidewalk width, and then the tree canopy, and traffic volumes, and so on. So, and then those features are impacting, influencing the individual's reactions as a sense of safety, sense of comfort, the level of interest, and so on, which is becoming the key to the pedestrian experience as a perception to the route. And then there was another empirical study basically asking people, so why did you choose that route? And then more than 80% of the people answered that they chose it because that's the shortest. So the time is the most important factor for them. But then actually in the decision-making process, it is not feasible for them to do so because due to the inadequacy of the information they can gather and compute, you can't know every single route, and then you can't know what's the actual distances. But then people are rather just relying on what their preferences or perceptions, which was determined from the past experiences. So, but they only can know what they have experienced. So when the information is not enough, people use maps and navigations. But they mostly offer just time-based information, which is this route is 1 minute slower, that's 2 minutes slower, etc. But we need more information about other attributes too, such as tree canopy, traffic volumes, or how greenery that the route is, how beautiful that is, based on these features that I introduced earlier. Only if we would like to care about what we experience in our pedestrian walking experience. So ultimately, the goal of this research is to offer the sufficient information that is other route options based on the personal preferences, so that we can have a better decision making, and then ultimately we can have a better walking experiences. And then, so in order to offer optimized route for a better walking experience, I needed to answer these 3 questions, which is how far do people want to walk more? Don't they want to, they just answer that they want to just find the shortest route. And then how if they want to do that, if are open to do that, how long are they are comfortable with walking more? And then also, how do we determine which route is better than the others? How do we make that decision? And then ultimately, how do we provide that information to the users? So I started to look at the San Francisco. Like many other large US cities, it has a grid pattern, and that which make the urban form more homogeneous, but at the same time, the segment has different characteristics. So which street segment is composing which route, that becomes the key to the pedestrian experience. So I looked at the over 22,000 foot traffic data of how pedestrians actually walked in San Francisco. That was data provided by the fitness app, and then which was completely anonymized for the research purpose. And then we with these data, we wanted to answer how far people would accept to detour. Do they really want to take the shortest route, as they said, or if not, how far they want to walk more? So from each trajectory's origin and destination, I computed the possible shortest route length. And then I divided the actual trajectory distance by the shortest path so that I can compute the detour ratio. And then on average, I've got 1.2. And then I regarded this number as how far people are comfortable with walking more. Then the next question I had was, how do we determine which route is better than the others? So I wanted to see if the urban attributes are really impacting the people's route choices. So I had these 4 different scenarios of a pedestrian flow model. The first one, shortest, detour allowed, distance weighted, attribute weighted. So basically the first one, in the first scenario, people are only taking the shortest route. In the second scenario, people are distributed equally to all different route options. And then in the third scenario, people are walking more frequently to the shortest route, and then it's distributed. And then the fourth scenario, attribute-weighted scenario, that's people are walking more based on the environment. And to talk a little more about this, the fourth scenario, attribute-weighted, so we borrowed this model from Alexander Eras's model, and then we computed this perceived distance. And then this is saying people perceived distance shorter or longer based on the environment. So for example, here, even though it says it's 120 meters, people perceive it as 70 meters because of the trees along the route. And then there were some examples of the coefficients from the model that he already computed. So with the greenery, people perceive it 23% shorter, and with an active frontage, 18% shorter, and so on. So we wanted to validate if that's correct, if that really works in the real world. So we got the 6 different locations, 6 different OD pairs from the San Francisco data. And then we computed, we predicted the actual, we predicted the foot traffic and then compared that with the actual data that we had. Oops. And then, and then that worked. So the attribute-weighted model worked the best. So now I know how I could calculate the perceived distance of each route, and then I know which route can be possibly preferred by the people based on their preferences. So now I wanted to design the platform that we can communicate which route is better than the others. So this is a video of a prototype. So here you just type the location, so your current location, which is an origin and destination. So, and then you got this set preferences so that you can set okay, I want to walk 15 minutes, the shortest is 10 minutes, and there are some features that you can choose. This is all conceptual, so like, oh, okay, I want a greenery along my route, and I want something less traffic from unfavorable. And then I can search, and possibly it can return this as my suggested route, optimized route based on my preferences. Or if I can be an explorer by just setting the area, which is just Chinatown, and then I want to walk for 20 minutes, and then it just returns me some random, but based on the preferences, routes, and then you can see the details as well. So this was just a conceptual prototype that I had, and then if you go to the next slide. Okay, and then I did some user studies. So these are 2 personas that I had. So Amy, she has been living there for like 5 years in that neighborhood, and then now she wants to find some hidden gems or find a new areas to visit. And then another one is Chris. He's just a newcomer to the town. He just moved, and then he wants to know which area would be perfect route for him to just walk around and so on. And that can be for the tourists as well. And then as I just show you, this is how it would work. You input origin and destination, walking time, and your interest, and then this computes the perceived distance, and then based on that, it can return the suggested preferred route. And then the other one, urban exploration. So you just type the area and the walking time, and then possibly you can return the route that you can explore. So I think it can contribute in many different ways. First of all, it can just drag out people from out of their comfort zone. So by giving them some like playful options to walk around, and then encourages people to just step out. And the next one is scalable. So because it's based on any data that has some geolocation, like the street trees, and then some POI data, how many shops do I have in this street segment, etc. Those can be easily translated into this. So possibly the public open data can be something, make it powerful and more scalable. And then also the accumulated data can be useful for the analyst, so that the preferences that people input, that can be something, okay, these are the preferences, these are the elements that the citizens more care about, or that's more desirable by the people. So that was this project. And then I am moving to the next project that I did. This is urban emotion. So here I wanted to measure emotion. So this one started from the question of how do we measure how we feel in public spaces? And how do we analyze this like user perception? So if we can measure how people perceive the places, and then wouldn't it be useful for the people, like designers, to understand how the places are actually used, and so that we can use it for the later. And then so we had this like very brave, rough assumption that so people may express what they feel and in the physical spaces on the social media. So how they feel, they express what they feel in the social media. And then we can capture that to understand how they perceive the space. So that was our very rough assumption. And then we started from the data collection. So we used the Instagram data, and then we ran the emotion analysis using natural language processing. And then we mapped it out, the results. So we started from about 10,000 data points, and then we filtered out some unuseful information, unuseful data, and then we ran the emotion analysis, and then it was returning the score, which is the confidence score, and the tone, which is categorized into 7 different emotions. So, and then we mapped it out. So these were the results of this project. So first of all, we started by just using these emojis on the map so that we can easily grasp what's going on by just a first glance. And then at first we started from there, but then we soon to realize that, okay, we need a temporal information too to look at this map, because, for example, if the plaza is used to protest by the people, and then the next day there's a festival going on, then the emotion people would express will be just totally different. So we wanted to see the temporal ranges, so we mapped it out in a different platform, so that we can explore more, analyze. But then actually in this project, like I said, it's a very, it was more of an experimental project rather than a really concrete research one, because we were using with the social media data, and then it was just, the users, that can't represent the whole group of people, because only a partial group of people are using the social media, and then that was the intrinsic limitation. And the second one, what they express on social media is often not what they actually feel or actually want to say about that. So that was another intrinsic limitation, to analyze the text directly posted by the users. And then the third one was the AI model wasn't trained for this particular analysis. So we used the IBM Watson tone analyzer, and then that was original purpose of it was to analyze the feedback analysis, the customer feedback or customer reviews. So the purpose of it was different, and then it was trained by another data set, another type of data set. So yeah, that was another limitation. However, the intention of this project overall was not to drive to any conclusion, but it's more, we wanted to just explore what's available and then what can be measured or analyzed throughout these NLP in the urban perception. So that was it for that project. And the third one I wanted to introduce was is this liminal ghettos. In this, I was measuring behavior. So this goal of this project was to understand how people have explored the city during the pandemic, and then how that's different from before the pandemic. So starting from the question of how segregated are we in the city, and has the pandemic worsened it? So during the pandemic, we kept traveling in the city with the restriction, but the mobility pattern has been changed. And then, like how people are traveling, how's the social when the social interaction was restricted, has the role of the public spaces has changed, or how is it acting during the pandemic and so on. So we wanted to measure that. So we used the Twitter data. We downloaded the data from January 8, 2018 to April 2021 in Bordeaux. And we got the data of users' unique ID, the coordinates, and the timestamps. With this data set, we were able to get the locations of where each users have tweeted. And we wanted to aggregate the data first so that we can have the whole city into smaller pieces. So we had this grid, and then basically this is saying, okay, user A tweeted in those locations and so on. With that data, since we didn't have any personal information with those Twitter data, we didn't have their income data. We don't know where they're living, so we couldn't estimate the income. So we are only able to estimate by looking at these locations they have tweeted, which is, so okay, that user A visited those places, and then those places, the average income of those places is that. So that's the user A's socioeconomic status. That's how we estimate it. And then by looking at the average deviation of each cell, so basically this is saying, okay, in this cell, these people with a diverse background or a very biased background have visited. So for example, if the cell is visited a very diverse background, we say that this is less segregated. Or if that place is visited by only the people who are visiting the rich area, then that's segregated, we assumed. So we calculated the segregation index. And then to talk about the grid, we subdivided, we used this dynamic grid. So we subdivided by the number of tweets in each grid. So meaning that we subdivided if the number of tweets in that area exceeds a threshold. So, and then subdivide again. So we wanted to show the distribution of the number of the tweets, and then we also wanted to keep the consistency of each grid cell, so we wanted to use this dynamic grid. And then after analysis, we were able to see some hotspots, which is dropped in integration or segregation. And then, so here, during the pandemic, those places were more segregated than before. And then Porto Airport and City Center, and then the resolution is so bad, but then like this historical area, I mean, these are highly related to the tourist activities, so that makes sense to have a less integration during the pandemic. But the more interesting thing is we were looking at the public spaces, and then those segregation index remained the same even during the pandemic. So that allows us to think about how important it is to the public spaces roles is during this kind of travel regulation. So here, this is how we visualize. This is representing how people moved around the city. And then this is the color represents income, and then so the segregation index that I talked about, that's represented as the wall height. So it's like a metaphor that having the height wall means it's more segregated than the other places and so on. So that's how we visualized. And then so this is a 2-minute video of explaining how the entire process worked. Thank you. So this is the interactive visualization we created. So you see, you can click on these buttons to explore the different time windows and so on. And then we had it exhibited in the Porto Design Biennale as well. And then, so that's all that I prepared today. And then, so I shared a few projects that I worked on, but then each project we try to measure different elements in terms of some human-centric perspective. But I'm not saying this saying that we need to measure these things during the smart city movement, etc. But then I wanted to just introduce some, and then I wanted to just have some inspirations, and then wanted you to just push forward, to think about which imagination we can go for beyond imagination, or we can go to just think about different directions when we think about this human-centric point of view. So thank you for listening.